Alright, so now we're going to get this script going. And I've got the beginning of the script on the screen. There is the radio unit, and the script is all about connecting the radio unit to the Arduino, and I've got 3 channels running out of there into the Arduino, and this is basically the script that does it. And you can see I've got 2 libraries just there. I've called it ballast in, routine, and snapshot, and they are 3 channels. One's attached to an arm, one's attached to a 3-way switch, and one's to a 2-way switch. This is the part where I print what I need to print, and I'm going to print now unballast in. So I'm uploading it to the Arduino. Now this is the arm on the radio control. Just going to show you what that looks like. So now that it's connected, I'm having a look at the serial port, and what I'm doing is just, as you can see, I'm moving that controller, and you can see that this is running between 2000 and down to around about 1000. And this is what I'm going to use to control the piston. So I'm turning that off, and now we're just going to have a bit of a look at the routine, which is a 3-way switch. So once again, uploading this, and now the serial port will show me what it's seeing from the 3-way switch. There we go. And this time I'll just click it that way, and that way, and that way. This is going to be the switch I'm going to use to surface and dive it a bit later on. But you can see it's hopping around between 900, 1400 and 2000 in a minute. Anyway, it did. So what I know from that, from the routine pin, that if I'm going to go over 1800 or less than, for example, 1290, I'm going to throw the switch. So I'm using this to get my span to work out exactly what I want to do, and I'm using it now for a 2-way switch. And this is telling me that I've misspelt snapshot. This Arduino does this for you. It doesn't let you make that many mistakes. So I'm uploading that now, and I'm going to do the same thing so that I can remember where what it is that I'm going to use in my formula as we go on. So I've now placed a 2-way switch on here, and now I've wired it up. I'm going to show you where all the wires go a bit later on. Circuit diagram will be there. But the notion is now I want to be able to use my controller to switch those 2 switches, and you can see them. You can see it working there, and that's all very, very nice. This is the circuit diagram as it is at the moment. I've got D6 and D7 running out to trigger those switches, and the switches are just using 4.8 volts now at the moment. So what I've done is I've put piston dive pin 4 and the other one, whatever that was, and here I've made them both outputs. And this is the simple bit of work. If unballast is less than that, make piston dive pin low, but if it's higher, make it high. It's interesting, with these switches they have to be low to turn them on and high to turn them off. So that's just simply how I'm using that arm and using the numbers that I observed before. So now I've added another battery, and I'm using that switch now to power the piston, and that's it. I'm using a different, I've assigned another channel here on the radio, and you can see that rocking around as it turns on and off. That's not the way around I wanted, so I'm going to change the wiring. Now I've added the distance sensor. Now this little bit of code here comes with the distance sensor, and I've loaded it up, I've wired it up, and you'll see it on the later wiring diagram how well that works. And what you can see there is it's seeing a particular distance. It's going up and down because I'm moving my hand in front of it. But that's looking pretty good. And now I've stripped that bit of code back and entered the important bits now, the bits that work, into my large diagram. So you can see I've added all those things. I have added this little bit of code here which starts it all up. And this little piece of code here. And that word range is the one now which we upload. I'm now going to read serial print range, and I've stripped everything back so that that's all we can see is that number. So it's reading the range nicely, around 98 to 100, 110. I'm moving my hand away, I'm moving it in, and you can see how that works. Now, I'm not particularly happy with that, and I'm just going to show you some more code that I've now added. This is a rounding code, and this is the setup material for it. And I'm using the number 10. I'm going to come back to that in a minute and explain what that means. I've added this little bit of code up here. I'm not going to explain what all of this means, but if you add the code yourself, even if you don't know what it means, it actually works. What it actually does, it changes the range into what I'm calling average distance. So it takes maybe, as it says at the top, 10 ranges in a row and then divides them into 10 and calls that the average range. So it gets rid of any little bits and pieces in the, little jerkiness in how this little thing operates. So we're just going to do the range, just like we did before, and up it comes. And if I just stop that now, you'll see in here there's 100 and 104. There's about 4 millimeters difference, and there could be a whole lot of reasons why that's occurring, but I don't like that. So instead now we're going to get rid of printing the range, and we're going to print instead the average distance, which has now been smoothed. Let's see what that looks like. This is an interesting bit of experimentation. Okay, it builds up to the number, and it's holding pretty well, as you can see. We've got 102, 103, it's 104 in there, I think. But there's not much movement at all. So if I go up here now to, if I put 100 in here, what's that going to do? So it's going to take, and it takes a lot of, I mean, this hammers through this material, so taking 100 isn't going to make a huge difference, I wouldn't think. Let's see what happens. Aha, it takes a while for the numbers to build up, doesn't it? When it gets there, it's sitting on 103 without moving. That's nice, that's pretty, but it takes a while to get there, and if the piston moves quickly, mind you, the piston doesn't move that quickly, that might be all right. So I'm going to replace that with 40. And let's have a look at that, uploading that to the Arduino. Yes, it makes 100 a lot more quickly, and that's actually not much different. That's pretty good. That's not bad. So in the averaging process, 40 might be around about the best. I'm just changing my the distance. I'll put my hand in front of the thing just to see what happens, and it moves quickly enough. That's pretty good. But for now, I think I'll leave it at 10, just to see how we go, just to test it. Yeah, you've got a little bit more variation in 10. Okay, so this is the wiring diagram. I've added a 7.2 volt battery to power the piston. You can see where the distance sensor goes into the Arduino. That's about it. It's all fairly self-explanatory, I think. It's not too difficult. Made sure the earths are joined together. You always do that. And that works the relay nicely. It's really great not having to have switches on here, micro switches. So I'm pulling the piston back to a, if you like, a pretend position. This has been sped up a little bit. So I'd like that to be my backstop. And the sensor, which you can see on this thing, is at 68. So now I'll move it this way, and I'll pretend I'm putting a stop in, measuring it on the screen, and that's 87. So here it is now in the code. Where are we? I've set an outer limit and I've set an inner limit of the piston. So if the average distance now is less than 87, outer limit is 1, else, and I don't need any of that, I get rid of that, else outer limit is 0. And when it reads 1, it's all go. When it reads 0, it'll stop. That's as simple as I need it to be, I think. You can see the logic in that, I think. So if unballast is greater than such and inner limit is equal to 1, then work them, and if it's the opposite way around and over limit is equal to 1, we will work them. In other words, it'll only work now within its range. So let's see how that works. Once again, it's a bit sped up, and that's it. It stops, it goes this way, it stops. Now that's pretty good. Yeah, I'm pretty happy with that. So now I want to add something to this, and I'm calling it a sweet spot. I want to take a snapshot of a spot which is going to be fluid. It depends. Every time I sail the boat, I want to explain this. So what this is saying is if snapshot is on, let sweet spot equal average distance. So what does that mean? I'm uploading this now to the Arduino, and unsnapshot in, of course, is my two-way switch. It didn't work. Why not? Because I didn't turn on that little bit of code, sweet spot. Now, it should work now. Yes, so sweet spot is 0, and if I flick that switch on the remote, it's 87. And when I flick the switch back, it's just remembering 77, isn't it? It's just staying at 77. That's good. So that will now remember a spot on the program. That's pretty sweet. So there we have it. So when I flick that switch, I remember a particular spot. Now I've added a bit of code here. It took me a while to do this. So if unroutine is, yeah, you've seen all this code already, I think. So if it's greater than sweet spot, inner sweet is equal to 1, or inner sweet is equal to 0. I had a bit of fun with these names. If inner sweet is equal to 1 and dive routine is equal to 1, then dive sweet will equal 1. Now this is where it all hits the road. If unballast in is greater than 1620 and inner limit is equal to 1, or dive sweet is equal to 1, then it will dive. Otherwise it won't. If unballast in is less than and outer limit is equal to 1, we've already done that, or surface routine is equal to 1 and outer limit is equal to 1, it will surface. Otherwise, nothing. Took me a little while. I didn't do that in 5 minutes. It took a little while to fiddle around with this. But ultimately it means this. If I use this arm, the diving arm, it goes down to the spot and stops. So imagine I'm in the water and I've just sent the boat to the bottom of the pond. Now I'm bringing the boat back up to the surface of the pond. And that's now at the maximum level. I'm bringing it back and I find neutral buoyancy, and it's there. I take a snapshot of it and put it on surface routine. I didn't explain that well enough, it's in the code. But when I put it on dive routine, it stops at the sweet spot. I can still drop it down further, or I can surface again. But that's a way of making sure you can get neutral buoyancy every time. And now I have to expand this out to 2 pistons and get 2 sensors working, and then have to add the pressure gauge. We're getting there. We're getting there. It's really fun. Hope that was relatively understandable. See you later.